Hello everybody, it's Mrs. C and I am coming to you with a video on our Unit 1 Simplifying and Evaluating Expressions. Now, I just want to explain to you how I came about actually creating this video. Why did I pick a video on this? Well, I was looking at our video catalog. So here's a shot of the video catalog that I will have shared with you in your Google Drive, and it shows you Unit 1. Unit 1 is going to cover three specific content skills. It's going, well, three-ish, maybe kind of four, because the first one is simplifying and evaluating. That is, where's my pen? That is this one. All right, so you've got the simplifying and the evaluating expressions. The second major thing is solving linear equations. And the third big thing is solving literal equations. So the first one is expressions, and the second and the third are actual equations. So we got a couple questions. What's the difference between an expression and an equation? What the heck is a linear? And what's a literal? So we've got a few questions, at least you should if you're thinking, and I got lots of answers for you. But the first thing I noticed when I looked at this video log wasn't this, and it wasn't this, it was this big blank space. I had no videos that I could find that were just simplifying and evaluating expressions. And while I erase my screen, let me explain to you why that is. Now, the reason why I don't have any videos for simplifying and evaluating is mainly because that's a pre-algebra skill. It's something that you should already know how to do, and so in most cases I just start here with the solving, which actually, by the way, is review as well. So this whole unit, with exception to the literals, is going to be review for you, and it's going to be the only time I probably ever review something that you've learned in years past. Everything from here on will just build on what you've learned in the past. So simplifying and evaluating expressions. Let's start with what is that? What does that mean? So to explain to you what that means, let me give you an example of an expression. Now, did you see that coming? 2 is an expression. It's a numerical expression. It's called a constant, and it is just the number 2. It expresses a value, and the value is 2. So is 2x. That's also an expression. 2x expresses the value of 2 times whatever the value of x is, and it will vary. That's why it's called a variable. I can do more. I can express a value by saying 2x, and whatever that is, then minus 3 from it. Take 3 away. So whatever the value of 2x is, taking 3 away is an expression of whatever that value is, and it depends on the value of x. So these are all expressions. Expressions can get crazy looking, or expressions can be really straightforward and simple. So let me give you an expression that is straightforward and simple. X plus 5. Notice there's no equal sign. If I put an equal sign, I turn it from an expression to an equal or an equation. We're not doing equations, we're doing expressions, which means there won't be any equal signs. Yay! We don't have to worry about that. So x plus 5 expresses a value. It is in its simplest form because these two terms cannot be combined. They are not alike, and therefore we can't put them together and say x and 5, you go together and make 5x. No, x and 5 don't go together to make 5 times x. I'll prove it to you. What if x was equal to 2? What would 2 plus 5 be? It would be 7. Now, what would 5 times 2 be? 5 times 2, if x was 2, would be 10. It doesn't work. You can't just put them together like that. So if it's in its simplest form, and you're asked to simplify it, oftentimes we just leave it alone. Now, is there something I could do to make this simplifiable? Well, sure. I would have to write an expression that has like terms. So let me just add a couple things. Let me put another x here, and another constant here. Now if I ask you to simplify this, there's a little bit of work to be done because we have like terms. We have a 2x and an x, and we have a 5 and a minus 3. I like to call it a negative 3. It sounds nicer. So a 2x and an x. How many x's do you have? 2x and 1 x is 3x. And what about the 5 and the negative 3? Last year you learned something from your teacher, Ms. J. Shout out. Woohoo! She taught you a really cool mnemonic device in order to remember your rules of combining integers. Same sign sum, different sign difference. Same sign sum, different sign difference. I will use that all year to help remind you. So are they same sign sum or are they different sign difference? They're different sign difference. So that means I subtract the 5 and the 3. I get a 2. And then there's a little continuation to the rule. Same sign sum, keep the sign. Different sign difference, sign of the higher number. 5 is bigger than 3, therefore the sign is positive. All review. If you're saying to yourself, I don't remember that rule, we're going to back you up to reviewing integer operations, and you're going to come see me immediately, and you're going to say, I don't know same sign sum. I do not know how you got positive 2. I thought the answer was negative 15. I'm confused. And then we're going to back up because you can't go any further if you don't retain the information you learned with Ms. J. Whoop, whoop. You got to have it. She did go through all that for a purpose because I'm going to be using it. So your final answer, always boxing, your final answer, 3x plus 2, is the same as 2x plus 1x plus 5 minus 3. It's just more simple. And therefore, it is the desired result. Let's try another one. Let me give you one that you have seen before. 2x minus 3 plus 5x minus 8. All right, I mixed things up a little bit, didn't I? I didn't put the x's with the other x's and the numbers with the numbers. I gave it a little bit of a saucification. Yes, I did. All right, so let's take a look. We have x's here and here, and doing a little color coding just because it's fun, and numbers here and here. They're called constants. So let me put my letters together. Let's combine the x's together, a 2x and a 5x. Are they same sign or different sign? In order to know, maybe I should put the sign of the 2x. Always assume to be positive if you don't see a negative. Same sign sum, keep the sign. 7x. And let's go to the constants. We have same sign or do we have different sign? We have, take a look. Same sign sum. Same sign sum, keep the sign. Well, I'm going to put the negative down now before I forget it. Same sign sum. Sum means add. 8 and 3 is 11. Final answer. 7x minus 11. All right, now I want to move on to the next page because I have some practice for you. Do you see the address up here? CUDA software. I've told you already in a previous video, CUDA software, an excellent place to go. I pulled these right off of free worksheets in the first section, which I think says numerical operations, and this is simplifying expressions. And I'm telling you that because I didn't take a screenshot of the answers. So if you do this as practice, you're going to want to take a look at what the answers are to make sure you're doing it correctly. Let's take a look at number 1. Now, they just have variables. There are no constants. That's not negative 6k plus 7k minus 2. So we're just going to combine like terms, the k's. So we have a negative 6k and a positive 7k. Different sign, find the difference. That's a 1. Sign of the higher number, positive k. I don't write all of that razzmatazz. I just write k. It's the same. You're asking, but is it okay if I put plus 1k? It's okay, but it's not what I want you to do in the future. Let's try to wean you off of those steps that are unnecessary. Okay, let's try something else. Let's come over here to number 2, 12r minus 8 minus 12. Which ones are alike? Is it the 12r and the 12? Or is it the 8 and the 12? Same, not same sign, sum. We want to find like terms in order to combine. So which ones are like terms? Hopefully you see it. It's the two constants, the 8 and the 12, the ones without the k. They did this to trick you, of course. They put a 12 on the r, thinking you would think these two are like terms and see if they could trick you up a little bit, but hopefully they didn't. So a negative 8 and a negative 12, same sign. Sum, keep the sign. That's going to be a negative 20. And the 12r, which has no other r to combine to, just comes down in the final answer. Why did you put the 12r in front? Well, I like to put my variables in the front if I can, and if it looks nice, and it does. I think a negative 20 plus 12r would look less pretty, and that's why I did that. Let's take a look at the next one. We have number 3. We have n's and we have constants. So let's combine the n's first. An n, positive n, and a positive 9n is 10n. And then negative 10 and a negative 3, same sign, sum. Keep the sign, negative 13. Hopefully you can do that almost right in your head. There's very little process to follow. I'm going to take you to the next page. I'm leaving this for you. Feel free to practice it. You know where the answers are on CUDA software. I'm going to take you to some saucier problems. All right. Now, I have not done a distributive property, meaning I have avoided anything that has parentheses in it. And now it's time to deal with that. So I'm going to go to the next page and just review briefly the distributive property. If you have a 5 times a quantity of 3x minus 4, you were taught to use the distributive property to multiply. And let's talk about why. I cannot combine a 3x and a 4. They're not like terms. So the rule, if you find parentheses, do everything in parentheses first. I can't. You remember PEMDAS. And you see the P that stands for parentheses is before the M that stands for multiplication. I like to put the M and the D together because you multiply and divide from left to right. It doesn't matter who comes first. In this case, it's just multiplying. The point being, I can't do parentheses first because there's nothing to do to a 3x and a negative 4. And that creates a problem. So we have the distributive property. The distributive property is a way of working around the rules of PEMDAS. Now, we're not breaking the rules. We're just working around them a little bit. And I mean around. We're going around this and around that. Now, what we're doing is multiplying because that's what 5 times the quantity of 3x minus 4 means. It means 5 3x's and 5 negative 4's. So let's just do that because I can multiply unlike terms. I just can't add and subtract. So 5 times 3 is 15. Don't forget the x. And 5 times negative 4, negative 20. All rules you should know. Negative times a negative is positive. Positive times a negative is negative. And there is my simplified form. 15x minus 20 is the answer. Let's clear this sheet. I could do it a little faster that way. Let me give you a different one. 2 times the quantity of x minus 3 plus 5 times the quantity of 3x minus 1. Now we have 2 parenthesis sets. We are supposed to do whatever's in parentheses first. We can't because they are not like terms. There's nothing left to do in the parentheses. If there was, I would do it, but I can't. So distributive property will help me get rid of those parentheses. 2x minus 6, and come over and do it again here. Watch this sign. If this had been a minus, I'm going to do a negative 5 times 3x. But it's not. It's a plus. So it's a positive 5 times 3x, which is 15x. See how the sign comes down? But it's not this sign. It's this times this sign. Positive times a positive is positive. Positive times a negative is negative. So it's really not the sign that's coming down. It's the product of the signs that comes down, or the value of that number. So now we're having negative 5, right? 5 times 1 is 5. Now my done, I wish I was, but I'm not. I did all this so that I could do this. 2x and 15x is 17x. Negative 6 and negative 5, same sign sum, negative 11. Okay, now, if we go back, I think, am I going back or forward? I'm not sure which. Going this way. Okay. You see that I just did a problem that's very similar to this one, this one, this one, this one, and this one. So I did an example of the hardest one. I didn't do an example of the easier one. So let's take one that's in this form. I'm making it up. I'm not keeping the same problems because I want to leave you practice and places to go for answers. So let me clear this and let me do an example that's similar. It looks something like this. Nope, it doesn't. It doesn't have an X there. I got it. Hang on. Okay. Similar to the ones that I had done before, but I did a harder one before. Now this one's a little easier because there's not 2 parenthesis sets. There's only 1. Who do you distribute? I've seen this mistake before. Now if I'm calling it a mistake, then clearly that's not what you want to do. This distribution belongs to the number that's timesing to the parentheses. It is not 5 times the quantity of 4x minus 8. It's 5 plus 2 times the quantity of 4x minus 8. So who did I say was times the quantity? It was the 2 times the quantity. So it's this. Easy said, multiply by the number touching the parenthesis. Okay? Okay. Bring down the 5 so you don't forget it. 2 times 4x is positive 8x. 2 times negative 8, negative 16. Combine, combine. Different signs. Find the difference. That's going to be a negative 11 and 8x. Now you're probably wondering, whoa, 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 why'd you put the 8x in front and the 11 in the back? Because I wanted to. Remember I said I like to put my letters in the front? So I just put my letter in the front. I move the 8x in the front. See, it's a positive. I just don't write it. And then the value of the 5 and the negative 16, which is negative 11. Easy breezy, lemon squeezy. Let me give you a different one. Very similar but different. How about now, aside from the numbers, the structure stayed the same. What is the major change here? You may or may not see it. It's this. This little subtraction sign, or this minus, or this negative, whatever you want to call it, is going to require you to distribute the negative. Every other time this has been a plus. And this becomes problematic for some of you because you think you're just supposed to bring down the signs that you see. Sometimes yes, sometimes no. And so it happens to be the same sign that comes down, but we never bring the sign down. We're always finding the product of the signs. So I'm just warning you ahead of time to be looking for that. So we have a, sorry, a little issue there, 6. Now, it's a negative 2 times a positive 5x. So what's a negative times a positive? Negative. What's 2 times 5? 10. And don't forget the x. Here we do it again. What's a negative times a positive? Negative. What's 2 times 3? 6. All right, so see, in this case, it stayed a negative with the 2. In the back end, with the positive 3, it's now a negative 6. So always multiply your signs is what I'm saying. Here, this is positive, right? So what is a positive 6 and a negative 6? It's nothing. They cancel out, leaving us negative 10x. Now, probably one of 3 things could be happening with you. You're completely confused. Don't worry about it. You're slightly confused. You need to practice. Piece of cake. You got this. You started falling asleep, but my voice is so endearing to you that you stayed with it for the sheer love of me. Awesome, move on. So you have to decide which are you. Totally confused, I told you don't worry about it. Mildly confused, I told you to practice. Got it, this is boring, but I love you, Mrs. C. You need to move on. So where are you and what is it that I want you to do? Okay. I'm backing you up. I want to say right now I need a separate video for evaluating because I only went through simplifying and looks like the video is, I'm trying to find my time and I can't, 20 minutes already, so I don't want to do any more than that. So I'll do another video on evaluating. This was just simplifying. When we come, oh, I know what I did. Hang on. Hey. I know what, sorry, I just hit the X button. Don't hit an X button when you're recording because the whole thing disappears. Hopefully I didn't lose anything because I was going to show you this. I was hitting too many buttons and definitely hit the wrong one. This is the one I wanted to show you. This is the video catalog. So if you were you were in the middle, mildly confused, I want you to practice the problems you just saw on the screen. Easy. Check the answers on CUDA. See if you're getting them right. If you totally know what you're doing, then you are just going to get yourself ready to assess with me. Take the practice assessment that I gave you, do the practice problems that I gave you, and if you ace it all, we're going to set up a time to test, and you are going to move on to solving linear equations. Don't wait. We got plenty to do. Now, if you are confused, meaning I just went over a bunch of stuff you don't understand, you need more practice in this area, you cannot move on. So I am going to direct you as to what videos to watch, or option, I am probably going to pull you and work with you individually and show you what practice you need to do so that you can be mildly confused, which means you just need to practice before you can feel like you totally got it and then you can assess. So everybody sitting out there knows what they need to do. Totally confused, you're just going to bring in your video log with the information and come see me and say, I'm totally confused, help. If you are mildly confused, you're going to turn this video off and go practice some problems, or when you come into class, you're going to jump right into practicing the problems so that we can turn the mildly confused into piece of cake. My piece of cakers, I just want you to do a couple more practice problems, show me or show yourself that you got it, and then you are moving on to the practice problems for solving linear equations so you can put to bed this section of solving linears, and then you're just one away from being done with Unit 1 and assessing, which would be halfway through the marking period. Oh my gosh, it's only like the first week of school. Okay, everybody know what they're doing? It's almost 23 minutes, not too bad. Hope you enjoyed it. Hope you know what you're doing. If not, I'm going to see you on the flip side.